Video just to summarise the main points from the lesson today. Yeah, good use of GDC in identifying what type of series we're dealing with. All right, the last few questions on the board had some nice structure. For each of these questions, find the sum of these series. So the decision-making process, the strategies you can employ are: one, basically ask yourself what type. And you know there's two types, the arithmetic and the geometric. Arithmetic, we're looking at D. Geometric, we're looking at R. And then there's a whole bunch of associated formulae attached to them. And the formulae I've got here, and you'll get one of these with every quiz or test or exam or anything you have. And look, the formulas are spelt out quite nicely in the very first section. Arithmetic, put nicely together. Geometric, put nicely together. There's an nth term formula, and there's a sum of n term formulas. All right, so the strategy for these questions is the same, whether it's arithmetic or geometric. It's just identifying what it is and then choosing the right formula. Okay, so let's go for it. Oh, sorry, part two. So once we've done what type it's two, is how many terms. So how many terms? And this is the u of n formula we need. And then once we've got that, part three is finding the sum. So that's using the Sn formula. Okay, so let's get to it. Let's grab this particular sequence. Let's copy it. Let's put another page in. Let's paste it. Okay. So let's just write down the first thing that we know, and that is u of 1. The first term here seems to be negative 11. Okay. And so what do we think it is? Well, the easiest thing to check is obviously if it's got a common difference. It looks like this goes up by 14, this goes up by 14. If you're not too sure, 3 subtract negative 11, 17 subtract 3. So we subtract successive terms, and this is 14, and this is 14. So it's arithmetic. Okay, so that's the important first step. We know it's arithmetic. Okay. This is u of 1, this is u of 2, this is u of 3. This exists somewhere along the sequence. It's u of n, but we don't know what this little guy n is. Is it 10, is it 12, is it 15? We know u of n is 283, so we're going to go straight away and we're going to write down the u of n formula for arithmetic. U of n is u of 1 plus n minus 1 times by d. Now just identify all the pieces that we've got here. We know that d is equal to 14. So we've got 14. We know that u1, the first term, is negative 11. We've got that. U of n, well, some people get confused, say, well, we don't know what n is. No, but we know u of n, because u of n is this number here, the last term in the sequence, 283. And we get to this last one by starting at u1 and jumping up a certain amount of d's. Okay, so that's what the formula represents. And n in here is basically what we're trying to find. So we've got this lovely thing here, and you can do some algebra and expand it and play with it, but we're going to reach straight to document. Oh no, I think we're okay here. Insert calculator. Alright, so menu, and then we're going to the magic of the algebra and the numerical solve. We're just going to type in that exact equation, 283. It can be the either way around, 283 equals, or the other way around. And it's going to be negative 11. The negative button is here underneath the 3. Negative 11 plus open bracket. I'm going to choose to keep with n. You can change it to any variable you want. N minus 1, close bracket, times by the 14. And the calculator, we need to program it to say solve, comma, for n. Boom! Okay, so n is 22. So there are 22 terms in this series. So now the sum formula, well, there's two formulas, isn't there? Let's just go and have a look at the formula sheet. This is the sum of arithmetic. So let's go and have a look at the sum of arithmetic. Here we go. There's two different formulas you can choose. You choose the one that's most appropriate. You know, for the second one, do I know n, the number of terms? Yeah, it's 22. Do I know the first term? Yeah, it's negative 11. Do I know the u of n term? Yeah. The last term is the 283. Okay, so I could use this one. Could I use the first one? Do I know n? Yes. u1, yes. n, yes. d. So I can use either formula. All right, so might not always be that way, but s of n, I'm going to put u of 1 Let's get my pen all sorted out. Actually, I'll change. N over 2, u of 1 plus u of n. Quite like that. So n over 2 is 22 over 2, and the first term is negative 11, and the last term, or the 22nd term, and that's u22, the 22nd term is the 283. And this time you put s of 22. So I've replaced n with 22 everywhere I see it. So s of 22, the sum of the first 22 terms. And so let's just go and type that in. 11, that's 22 divided by 2, times by brackets negative 11 plus 283. Okay, so that's 2992. Fabulous. All right, let's go for the second question. So you can probably guess that first one was arithmetic. You're probably guessing this is going to be geometric. I think you'd be right, but let's just go through the same process. So there you go. So find the sum. So first of all, we need to find out if it's arithmetic or geometric. So let's have a little think about it. Oh, got like yellow. What's the rule from getting from one term to the other? Well, it looks like it's too big a jump for addition or subtraction. So I'm going to try the common ratio. And remember, the second divided by the first, or the third divided by the second. And each time you can see that that's equal to 3. So it's actually times by 3. The common ratio is 3. So r equals 3, u of 1 equals negative 4, u of n is negative 78,732. This is u1, u2, u3, and this is u of n. Okay? So we want to find the sum of all those terms. First of all, we need to want to know how many. So we need a u of n formula again. So let's look, it's exactly the same structure as before, u of n formula. We know it's a geometric. So now we go to our formula book. And geometric, u of n equals u1 into r to the n minus 1. Just get rid of a little bit of that there, make it a little bit clearer. N minus 1. And notice the n minus 1 is all up in the exponent. Okay, so let's substitute what we know in. un, the last term, is negative 78,732. And we jump to the last term by starting at u1, the first term, negative 4, and multiplying it by r to the exponent, n minus 1. Remember, it's the n we're trying to find. So, let's get to our GDC again. Menu, algebra, numerical solve, and we type in the equation again. Negative 78,732 is equal to negative 4 times by, I'm going to put the 3 in brackets, don't think there's anything to, and the exponent is a little hat button, kind of next to the 4. The power of n minus 1, and then press the right arrow, and then comma, and n. Boom, 10. So there are 10 terms in this series, n equals 10. So finally, s of n. So we need a sum formula from the geometric. Sn is u1 r to the n minus 1 over r minus 1. It looks like they've flipped the things around here. I'm just going to use this first formula. Write it down. U of 1, r to the n. Notice this time the minus 1. Okay, so let me just highlight that subtle change. Whoop, get off. So here, r to the n minus 1, all in the exponent. Here, only r to the n. And then the minus 1 you can see is actually on the same line as the r. Okay? So they are different in terms of how it treats their exponents there. And this is all divided by r minus 1. So the sum of the first 10 terms is u of 1. Now what's u of 1 again? Go back to the beginning, negative 4. Into r was 3. 3 to the n, 10 terms, and then subtract 1. And the denominator, 3 minus 1, which I know is 2. So calculator again. And we just type in the equation we've got to solve. Negative 4 times by, open bracket, 3 to the 10, arrow to the right, and then subtract 1. The answer to that is this, and of course the whole thing is divided by 2. Okay, so I'm typing that answer. That's negative 118,096. Okay, so that's the power of the calculator. Lovely. Yeah, that should do the trick, I think.